Hi, so in this video I will do this section, the USB 2 micro and ESD protection. I can see what left here. I have all components related to the USB. And I have this R7, which is this one here. So the pull-up resistor that goes to an RCD. Just move it and put it somewhere here because I have my, yes, so this is a perfect placement because I can connect it like this and then here and then the 3.3 it can go here. And remove the designator. So the USB can be just for now here. Then this ESD protection, let me just put it here for now and then this here. So what you see here is the ESD protection and then the C3 here, which is going to pin 5. So it's going to this pin here. Let me remove the designators. So if I place it somewhere like this, so I can see I might need to go a little bit down with this section. So then I have my connection from USB 1 and USB 1DN. It will go immediately here on my differential pair, and then it will go to those pins, the USB. So I will just put this USB like a little bit down. It can be closer as well. And then my VBus, it can be somewhere here. Then I can connect the VBus and the ground as well. So all this, it can be also closer. So something like this. So this USB, as we talked about, it needs to have an impedance matching of 90 ohm. So that's when we, in our schematic, we defined it as differential pairs. So first thing we need to calculate the trace width of our traces going from here all the way to the microcontroller, and we need to also define the spacing between those two lines. To do that, simply you go to GLC PCB, then you write GLC PCB impedance calculator, which is here. And then you select from here. So we don't have coplanar differential pair. That's if you have a ground on the top layer, you use it. So we're gonna use this. Then you select the impedance, 90 ohm. And then select millimeter. You can keep mile if you're comfortable with miles. So millimeter here. And then calculate. So here it depends on your the stack up that we talked about before. So I'm using this stack up. And that's also how I defined it on my stack up here. So yes, it should be in this window here. Design, stack up manager. So this is my stack up, and you can see I wrote a note which stack up I'm using. So back here, so I'm using this stack up here. I can see that the trace width, it should be 0.1582. So this is for my data line. And then the spacing, it should be between them 0.2. And that will give me impedance matching of 90 ohm. So simply what I do, I close this, the stack up. I don't need it anymore. Then I can go to design, then rules, then routing, differential pair. So then I created, already I did one. I create a new rule here. And then I call it, for example, diff 90. And then here, where the object matches. So I already have this differential pair. So I selected with, sorry. So I have it as a class. So all differential pairs. So if you have different differential pairs for other USB or whatever you have, then it will show you the rest. But for us, we just have this div 90, which we defined it on the schematic. So then you have to just write the numbers you get from GLC PCB. So you write the trace width and then the spacing. I will show you how I did it here. So I don't need this because I already have a rule. So if we go here, you can see the preferred widths. I just wrote it 0.1582. And then I already defined the gap, which is 0.203, which giving me here trace space, which is the gap. So just I blocked these numbers here, and then I made apply. Okay. Let me we don't need the schematic anymore. Let me merge all. Then so now I don't have to worry about my trace width for the differential pair. I already defined it in Altium. Then what I simply do, I go to route, quick differential pair. Then I just left click and I bring my differential pair here. Place them here. Then I go all the way, left click, left click. So now I have perfect differential pair lines. And the gap between them is, we can check actually, it should be 0.2. Yeah, which is 0.203, that's correct. And then my trace width, it should be 0.15. Then Shift C to remove the measurement. Remember those differential pair, they must be symmetric. So they are identical, as you can see here. It's identical here and here and there, over here and over here. And that's simply how you do the differential pair. So even if you have 90 ohm, 50 ohm, it's exactly the same principle. So Altium as well can calculate the trace width for you. And to do that, you go to design, then layer stack up manager. So then you go to impedance and then add impedance profile. So here we have a differential, then 90 ohm, Then you have to select the reference. So in our case, we have the routing on layer 1 and the reference is our ground, layer 2. So I remove those. And I select my layer 1 here. And then I select the reference. So you can see Altium highlight those two. And this is this is the correct connection because we have the differential pair here on the top. And then we have the reference plane, which is in layer 2. Then we have our gap. It's 0.2 here. So this you can change. When you change the gap from here, the trace width will change. And then I can put it here and calculate. So Altium actually give me 0.155 and we got 1.158. So it's super close. And remember, it can be 9% tolerance. That's not an issue. So Altium did well with the calculation as well. I think the only thing we missing to have it perfect match is this for solder mask dielectric. Those, when I told you in the lecture, you have to contact GLC-PCB and they give you the correct numbers. We don't have them here. And that's why maybe it's a little bit different, slightly, but also it works well and it does correct job. Then you can have the description and you call it div90. So this is just an alternative way to calculate the impedance. But personally, if because I'm using GLC PCB, and they already have tools to calculate the impedance, I prefer to use their calculator because they know their material exactly and they will give a better result. So just if you use another manufacturer and they don't have a calculator, then you can also use Altium and use this alternative way we talked about. So I don't really need this. So that's it about the impedance matching and the USB. Thank you.